Guys, welcome to another section of our studies, which is about differentiation from the first principle. That is understanding differentiation from the first principle. Now, what is first principle's differentiation? The first principle differentiation of a function f of x is denoted as f prime of x, f first of x. That is the first differentiation, where the f prime of x will be the same as dy over dx equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. We got this idea from the understanding of the birth of differentiation from our previous video. The key concepts about this particular equation or expression is such that h represents a small change in x, and the numerator, that is f of x plus h minus f of x, represents the change in the output. Then the entire expression gives the average range of change over the interval h. So the average range of change over the interval h is represented by the entire expression. So as h gets closer to 0, we get the instantaneous rate of change, which is the derivative. That means when h is getting closer to 0, the secant line becomes the same as the tangent line. If you've watched our previous video, you understand the meaning of the secant line and the tangent line. Now let's look at the steps to find or to differentiate using the first principle. Now, number one is for us to write the function y equal to f of x. Then the next step is to substitute the x plus h into the function and express it. After finding your expanded expression from the step 2, you find the difference between the f of x plus h minus f of x, that is the numerator, and divide the result in step 3 by h. After doing that, so if we are going to divide it by h, it means we are going to divide the numerator, that is the expression from the step 3, by h. Then we take the limit as h approaches 0. That is where the secant becomes the same as the tangent. So in doing that, taking the limit as h approaches 0 of this particular function will be differentiation from the first principle, which is dy divided by x dx. That is change in y over change in x. That will give us the derivative of the function f of x. Now, let's work on an example that is derivative from the first principle, finding dy over dx using the first principle. Let's look at the first example. We have f of x equal to 2x. What is the solution? First, we let f of x be equal to 2x. Then we find our f of x plus h. It means that this x is the input for this function. So now the input is now going to be x plus h. Anywhere we see x, we substitute s plus h. Here is it, s plus h is here. Then we expand and simplify this expression. So the expansion will be 2x plus 2h. Then we find the numerator, which is f of x plus h minus f of x. In doing that, to be 2x plus 2h minus f of x, which is 2x. So our results, minus 2x will cancel 2h, then we get our results to be 2h. Now we are going to find f of x plus h minus f of x divided by h. When you do that, the result for the numerator is 2h. So 2h divided by h will be equal to 2. Then I'll find the limit, that is dy dx will be equal to the limit h approaches 0 of f of x plus h minus f of x divided by h. So in writing the expression here, we are going to have dy over dx, that is the first differentiation, first derivative, equal to the limit as h approaches 0 of 2. Limit of a constant is the same constant. So it means that the dy dx of this function using the first principle will be equal to 2. Now let's proceed to the next example, which is f of x equal to x squared. What will be the solution? The input here is x, so I will substitute x plus h as my new input in this particular function, and we are going to end up with x plus h all squared. And when you expand this expression, we are going to have x squared plus 2xh plus h squared. Then we find the numerator, which is f of x plus h minus f of x. So the x plus h, f of x plus h was expanded as this expression here, minus the x squared. So the x squared represents the f of x. So remember, x squared, positive x squared will cancel negative x squared, and our final result will be 2xh plus h squared. So here we have f of x plus h minus f of x divided by h. So I have this expression in this form. So 2xh plus h squared divided by h. Then h is repeating itself in each term of the numerator. H is here and h is here. So I'll factorize the h out, then divide everything by h. In doing that, h and h will cancel. Then our result for f of x plus h minus f of x divided by h will be 2x plus h. Now, we are going to have the limit as h approaches 0 of this particular expression, which will be equal to the limit as h approaches 0 of 2x plus h. That is the result. Then the limit h approaches 0 of 2x plus h equal to 2x plus 0. Remember, 2x plus 0, which means that if h is approaching 0, I will substitute 0 as my approximate number for h and find the approximate number for the function that is in the form of f of x equal to x squared. So here my approximate function for the 2x plus h will be equal to 2x. It means that the limit as h approaches 0 of 2x plus h is equal to 2x. So it means our differentiation dy dx is equal to 2x. Now let's work on another example, which is f of x equal to x power 3. In this form, we need to understand that the input is x. So anywhere I see x, I will substitute the expression in. So the expression expansion will be x cubed plus 3x squared h plus 3sh squared plus h power 3 when you expand this particular expression. And that will produce the numerator in the form of f of x plus h minus f of x. So it means that I am going to subtract f of x from this particular result. When you do that, x cubed and minus x cubed will cancel. Then our end product will be 3x squared h plus 3sh squared plus h squared. So that is the answer for f of x plus h minus f of x. So we are supposed to find the change, that is f of x plus h minus f of x divided by h. So we do that and factorize the h out. Why? Because h is repeating itself in each of these terms, that is the terms of the numerator. H and h will cancel. Then we are going to end up with 3x squared plus 3sh plus h squared. So it means that dy dx, which is the first principle, the first derivative, will be the limit as h approaches 0 of this expression. So the whole of this expression produces this particular result. So that means we are going to have the limit as h approaches 0 of 3x squared plus 3sh plus h squared. So the limit h approaches 0 of this expression means we are going to have an approximate value of 0 for h. Anywhere we see h, that will be 0. So when you substitute 0 here and 0 here, our end result will be dy dx equal to 3x squared. So the derivative for f of x using the first principle is equal to 3x squared. Now, let's move to another example that deals with a fraction. We have to understand these steps. We have to compute f of x plus h. So computing f of x plus h will be anywhere you see x, substitute your x plus h. Then the next step is to subtract f of x from the f of x plus h and have your numerator. So it means that f of x plus h minus f of x equal to 1 over x plus h minus 1 over x. When you do that, we have to find a common denominator. It means we are going to solve and simplify this expression completely. So here, when you simplify the expression, the LCM will be x plus h. That's the LCM. And when you solve the numerator here, to be x minus x plus h. X goes here, x plus h, and you multiply the results by the 1. Then x plus h goes here, x multiply the result by the 1. Then we end up having a numerator of the form x minus x plus h divided by x plus h. Then remember, minus x will cancel positive x, and minus will affect the h. So we have minus h divided by x into bracket s plus h. Then our next step is to find or divide this whole expression by h. So here we are going to have f of s plus h minus f of a divided by h. So I'm using the division sign here for you to understand the concept. And when you have the division sign, it will change to be multiplication. And when you do that, it's going to be negative h over s plus h, s into bracket s plus a times 1 over h. Remember, h and h will cancel. Numerator will multiply numerator, denominator will multiply denominator, and we are going to end up with negative 1. When h and h cancel, here will be negative 1 times 1, that will be negative 1 divided by here will be 1. The whole expression times 1 will give us x into brackets s plus h. So now we are going to find our dy over dx, which is limit as h approaches 0 of this function. So this expression, rather, we are going to have limit as h approaches 0 minus 1 divided by x into bracket x plus h. Anywhere we see h, it will be 0. So when you put 0 here, here will be 0. So s times x will be x squared. So our dy ds will be equal to minus 1 over x squared. So we have a practice section for you to try your hands on to find from the first principle the derivative of the following function I, and I. And this is a very unique example for you to try your hands on. That is, f of x is x plus 2, g of x equal to 2x squared minus 3x. Find j composite f of x all prime. That means the derivative of this particular function. Don't forget to subscribe to this particular channel and continue to receive the best of high school math education. And solve this particular problem and send it to our platform or the comment section for us to go through it for you to give you feedback. Thank you.